In this segment what we will see is we had a claim that in the previous segment that all the motions will be periodic, whatever means whatever way you start the system, it will going to be periodic. We in a way we did that in the previous segment when we when you derived this equation of the wave, it showed you that actually it is periodic, and then it is periodic for any initial condition, right? Because this is how, what are the initial condition? This is one initial condition, this is another initial condition, right? So these are the only two ways with which you can start this system. Means any arbitrary initial condition means you are the owner of these two functions, y naught z, v naught z. So once you choose them, the system will start. Now this way we showed that for any value, any function you choose, the function which you get here is periodic with periodicity of 2L. So that is one semi-quantitative way of seeing the periodicity of the thing, but now we will look properly how what is the meaning of periodicity, and then from there in fact we will get into the concept of modes and the point which you are making, the nodes and antinodes and everything. Okay. So how did we do mathematically when we were dealing with 2 degree of freedom system to see the modes? Because see, from where this thought process coming, I am just telling you. We qualitatively saw that the motion has to be periodic. Okay, previous segment the functions were periodic for satisfying both the boundary conditions. But then we also had said earlier or seen earlier that any periodic function can be broken into harmonics, Fourier series, right? Now if that is so, that means there must be some harmonics which are building up these periodic things. In that way also you can argue, then what are those harmonics which are building up these periodic functions? And the same argument for the 2 degree of freedom system or the 3 degree of freedom system, if you consider, I can say that okay, any motion will be periodic, but there you can't say that. Okay, there we said that okay, let's see if there are some periodic motion, what are they, and then we came up with the thing that okay, any motion is a combination of these two, but they may or may not be periodic. But here we are slightly changing the argument in a way, because we know a priori that it has to be periodic. We are saying that any motion which will happen will definitely be periodic, and obviously periodic motions will be from the harmonics, the sinusoids. So then let us try to find out those sinusoids, and most probably those will be the modes, and if those are the modes which will take place in sinusoid motion, what is the way to figure them out? If you remember the way we figured them out for 2 degree of freedom system. In 2 degree of freedom system, what did we do? We said that we said say x is equal to a e raised to minus I omega t and y is equal to b e raised to minus I omega t. So this we kept constant, and a's and b's we changed. So that is how we imposed our requirement that everything moves in sync, which meant that we are trying to find out the modes because that is how we defined the modes, right, where everybody is moving in sync. So now we will use the same concept of mode to start our equations. That means we want that our y xt, okay, will be, you know, or if I say, I'll just change it to yt. If I say that, suppose y of x times e raised to minus I omega t. Okay, so this can be okay, y xt, yeah, that was fine, whatever I had written. So xt, that's fine. So just look at this and this. They are the same things, right? Because now there are no specific discrete points. So we are just telling the same thing. So at every x, there is one yx basically, which is like a's and b's. Because now at every x there is a and there is a b. So how many such infinite number of a's and b's can we write? So instead of that, we are just writing this. Okay. And now if you substitute this in the wave equation, you will get the differential equation which will be only in, so your wave equation I haven't written anywhere, so I'll just write it here. Say right. So this is what we are trying to we are wishing that this will satisfy this, and we are imposing the condition that, or we are looking for the possibility that are there some shapes which will move with same omega. So that means every point now, every x is moving in sync. So that is the same statement we have just shifted here from discrete to continuous. And there also you did the same thing. These equations, you substituted them back in the equation of motion. So here also you are doing the same thing. You are substituting it back in the equation of motion. Right? So if you do that, you will get the equation which will come, x square plus omega over c square y0, where c square is t over rho. Okay. Now, and there also you got the similar equations in terms of different x's and y's, and here you are getting as a function yx. We are doing nothing but avoiding writing infinite number of discrete points, that's it. Now the solution of this will be what? Y, so and then because the time dependence is gone, so you are having, instead of partial, you are having the complete differentials. Yeah, so y of x now will become, say, c plus e raised to minus, or okay, plus I omega x over c plus c minus e minus I omega x over c. Okay. So that means you now have complete y x of t, right? No, not x of t, y of x and t is this times this. So you can also write, c plus e raised to plus I omega over c x minus ct, okay, plus c minus minus I omega over c x plus ct. Just check whether you are getting this or not. So here it's plus, so I omega c, this minus, so omega t. So here it's minus, here minus, here minus, yeah, fine, right? Now in fact, so now you are able to see that the solution is having, so this side is the right moving wave, and this side is the left moving wave, because x plus ct, x minus ct. If the argument is of that form, you know in which direction they are moving. And again, whenever you see complex number, tell yourself, don't worry, finally the real parts will be the thing which are of importance. Again in this case, though this thing is getting represented by a complex number, the physical wave displacement will be the real part of this. And we could have chosen everywhere, means in the full course we could have chosen this, instead of this to be the dependence, we could have chosen e raised to I omega t also, or I'll write say j omega t. Instead of minus I omega t, I could have written j omega t, because say I is equal to say plus minus 1 and j is equal to say minus or the opposite maybe. Yeah, minus I and j is say plus, what am I writing? Yeah, whatever. So minus 1 and this is plus of minus 1. You can define like that, because this will have a plus or minus, and this you could have chosen plus, and then there is no specific reason why should we choose one and why not the other, because both of them are same, because they are the square root of minus 1. But we specifically chose this one to be maybe, and we are putting this minus I omega t everywhere. Had we chosen j, it would have been plus. But why we chose that is one of the reason being this, that just by seeing in this expression, you can just tell that this is the forward moving, positive moving. The coefficient of x will tell you. Minus x means negative direction, plus x means positive direction. Okay, so that's why this this convention is helpful in just recognizing from here in what direction things are moving immediately. Now there are certain points. For example, this form, omega over c x minus ct. This can also be written as omega times, or see this okay, I'll write that omega over c x minus omega t, but then this has got a name attached to it. We generally write k x small k, okay, x minus omega t, and this is called the wave number. Okay. Now, what does that signify physically? See, it's something related to the wavelength of the snapshots when you took. There were two viewpoints. One was the snap, one was the person sitting at a particular point. Now they will draw two different pictures. Now there will be a ratio in their x-axis. So this has something to do with that. Okay. Now you see this here. If I change x to x lambda so that an increment of 2 pi happens, then that means the shape will repeat itself, isn't it? So that means you can say that so 2 pi, how do I say, this is 2 pi f frequency over c is equal to k. Now you know that c is equal to fr times lambda. Okay, so that means your fr over c is nothing but 1 over lambda. So this is equal to k. So that means this is 2 pi over lambda. So compare this with omega, which is what? 2 pi over t. So this wave number is like the angular frequency for space. Like, that's why I said like angular frequency for space, so that lambda is like time period in space, right? So the expressions are exactly same. So that is why wave number is like omega for space. Okay. And that's why they are sitting also very similar positions, right? X के साथ k है, then you have omega with t. And this minus is just for that i's circus. Minus I की जगह पे plus I होता था. Okay. So that's the reason. And then, or you can say that this minus is for forward moving or backward moving, but the nature of the thing. So that means now if you see in space, the if you calculate when again it is getting repeated, so that means this is, so lambda and 2 pi over lambda will give you the wave number, and then similarly in time, if somebody draws it standing at a particular location, he will get omega. Okay, so that's about one of the, so this is one of the expression which almost all the books will write this, not omega by cx but kx minus omega t. Okay, so this expression you try to, I'll write it so that once it will stay. So your y xt is nothing but c plus e raised to say plus I k x minus ct omega t plus c minus e raised to minus I kx plus omega minus omega t, right? So that's what we had got, or what, or oh plus, okay, yeah. So that's how you will always see the thing. And then this one you can always open that and write in the real part of this expression, which will give you the actual physical displacement. Now again, whenever you see complex number, though you shouldn't get worry about it, but you should also see what information it hides inside. Okay, that means this C plus will have some a times e raised to minus I phi, right? Because any complex number, so these are complex numbers, so they will have their own amplitude and phase information. So either you write them as real and imaginary, or amplitude and phase. And similarly here it will be a, say, b e raised to minus I phi minus and plus are there. So these are those things which because you have two boundary conditions now, so you have four informations which are now arbitrary. How much time we have? Oh, we are done. Okay, because I wanted, okay, I'll just tell what we are going to discuss in the next segment and I'll stop there. So what we are going to do is, we will see what happens when these amplitudes become same, that A is equal to B, okay, and that will come to the point where we will talk about the standing waves. Okay, that means A equal to B means what? At the other reflection also no energy was absorbed, so everything came back basically, because these amplitudes are nothing but their square is proportional to energy always, right? So if amplitudes are same, means the same energy is coming back, no energy is actually getting lost anywhere, and in that case you will have a standing wave formation. So from this standing wave we will come to the points where we will discuss about the nodes, antinodes, and we will see the reason why they are happening, and yeah, and then from there we will see even the summation of the modes, how they give rise to different conditions. All those things we will see in the next segment. Okay, we will stop here.